thank you everybody, and Llewellyn, Phil, thank you very much. That was fascinating, and I love the perspective that you bring. I also appreciate being teed up. We are not going to have to wait a year to see or hear about a case study of how AI is being leveraged by not just a utility, but utilities in the telecom space, in the NOC specifically. As we jump into it, my name is Adam Nathan. I am the Director of Sales for Utility and Energy at Worldwide Technology. If you could go introduce ourselves.
Sure. Behind you.
It's hidden.
Good morning, afternoon. Marc Spieler, I'm the Global Head of Energy at NVIDIA.
Matt Deibel, I'm the Manager of Grid Automation Services. So we do network infrastructure automation, software engineering, and AI engineering and strategy.
I'm Ken Rabedeau. I'm Head of Energy Segments at Nokia. And I know most of you are familiar with us as a communications company, but more and more with AI being such a buzzword, we're getting lots of requests for what are we going to do, how are we going to bring it. And we're going to talk a little bit about that.
Awesome. Well, I know a lot of people this week were talking about how the grid will be built out in order to support AI, but we're also not forgetting that utilities themselves are starting to use it and play with it and see value. And so we have one of those examples here, specifically about how a utility NOC is starting to leverage generative AI in their NOC operations. And so before we jump into the demo, we're going to do a very brief demo of what's being built, but want to give a little bit of the background here. So Matt, you want to speak a little bit to the initial impetus by SoCal Edison to work on this effort, and a little bit about what SCE had been trying to do to date, and what were the challenges the team was facing?
Yeah, so in our space, network infrastructure, we've had a lot of challenges with how much we manage, operate, right? You look at our NOC, we support at SCE all the way from the grid apps, all the way layers 1 to 7, right? So we got infrastructure, we got network, we got wireless edge network, right? So it's really challenging for us to manage all those disparate technological stacks, right? So a NOC operator might get a call from a grid operator, hey, I'm trying to operate this reclosure over here on the line, right? And it's not working. Oh, is that an issue with the software? Is that something that happened with the servers? Did someone patch a server? Is that maybe your last mile wireless edge, right? So it's really challenging in that space, prime for having AI to help situational awareness, right? And then let's just add to that space, right? We are evolving. So Edison just in September went go live with our 5G deployment, right? So now that NOC, who is operating our legacy wireless network, is now responsible for operating this brand new wireless network, right? Imagine all the things being put on these people here. So we found this as a great use case. Hey, let's look at AI. How can we leverage AI to give these people awareness of all the different tech stacks and really help them support that from a level 1 troubleshooting, right? Very interesting conversation this morning with my team even on just the impacts here. It's a very interesting conversation in the network and telecommunications space. So with that, we approached some of our partners with this use case, and we got WWT, NVIDIA involved, and set up this workshop on site. And I think, Adam, you're going to speak a little bit to that.
Yeah, so basically really the goal of the initial workshop was just let's marry some knowledge about what the technology can do with the needs of the NOC and start to think about where can this start, what would deliver value. So we started out sharing the art of the possible, what we're seeing from using it at Worldwide Technology and NVIDIA using it. Then we went and toured the NOC and really got to see and hear about some of the challenges and operational complexities that are going on in that space for SCE. And then we spent a few hours ideating, and what sort of stuck out to me was it was not we got everyone in the room, and it was not, the challenge was not finding ideas for how to use this technology to apply it and make the job better. It was really, we had too many ideas to really get started, and we had to figure out where to start. So Matt, you want to speak a little bit about where we started, and that'll tee up the demo of what we've been building so far.
Yeah, perfect. There's so many use cases, right? We can go on, and we needed to start somewhere. And we also wanted to build a strategy, right? I'm glad there was a lot of conversation before us about the compliance and regulatory state of it, right? That's challenging for us as a utility when it comes to AI. A lot of our data sets in the network space, right, have maybe NERC implications. So we have to work on our infrastructure to actually build out use cases. And fortunately, with our partnership with WT, we were able to leverage their ATC lab and target some use cases around public documentation, manuals, and troubleshooting guides, and even scrub versions of our internal runbooks, right, that allowed us to basically stand up a RAG Gen AI implementation. And that kind of led us to this first use case that we're going to demo for you guys right now.
All right. So we're going to start the demo once it's on the screen. All right.
Yeah, and we're just setting the landscape here. I know it's been me and Adam a lot here, and we're going to have Marc and Ken get to fill in a little bit here. We're just setting the landscape a little bit. So with that use case, right, we have an operator who's maybe new to the job, and he gets this alarm. This is a specific technology platform. This is a DMX 1665 Sonnet platform, right? So you can see he's trying to ask some questions. Let's just take, for example, he's going to use Google to try to figure out what this is. He never dealt with DMX before, right? And you can see Google had just a lot of various links, no context. Maybe he goes to ChatGPT. He's going to look at this same question, try to get some context around it. This is a big problem I want to point out with AI, right? It's hallucination. So I just know from knowing this technology that what's being presented here by ChatGPT is inaccurate. If we're presenting solutions to our operators to make decisions, it has to be highly accurate, right? So we can't rely on that. Then this is our internal set of manuals. You can see as he scrolls all the different technology platforms. So someone trying to go look through our manuals to find a specific device platform and then be able to scroll through that and try to figure out what's the context of the alarm, what's he trying to troubleshoot, how might he troubleshoot it, right? You can even use the find function, and you can maybe get bits and pieces. But the point to show you here is it's hard in a very short period of time for an operator to get context about an alarm and have quick decision pieces of here's the next step I can take to try to resolve this, right? This is a big time waste for them to go dig around through manuals or the different things available to them today. And it doesn't provide us that good context. So we stood this up. This has actually only been like, I want to say 3 months total, maybe 2 months of actually working, 3 months from the workshop. Very quickly stood this up. This is internal RAG. This is in the ATC AI Proving Grounds today. We provided them those same manuals you saw. Same question. You can see very relevant contextual information provided here on the screen, right? Telling you what that card, that module does, right? The different SFPs. You can ask follow-up questions about compatibility, get a lot more context around any of the problems you're seeing, right? And you can see the relevance of the answers. You know, this might not make sense to some of you guys unless you're familiar with the DMX platform, but for operators and what they're seeing on their screen, this has a lot of relevance. And then let's just ask something very tangible. How do you troubleshoot that alarm that they're seeing on the screen, right? And you can see they're bringing back information, even quoting different manuals. So you can see that hallucination that we're worried about can be alleviated by showing what is the source of the information we're getting, right? And give them relevant info. So at their fingertips, they already know exactly what page they need to go to. And like I shared, we're only 2 months into this. We're looking right now at even bringing in context around digging into what is that page 513, what is the steps there in that troubleshooting, and add even more context to this. So the evolution and the quickness to deliver that you see when you deliver these things is amazing, and how much context you can provide in a short period of time.
Awesome. Thanks, Matt. So this is just one example of how one utility is using generative AI today to help improve their operational processes. I do want to tee up Marc here. I guess NVIDIA works with a lot of utilities around the industry. How are they building their AI business cases, and how are they getting started?
Thanks, Adam. So utilities are moving at very different speeds, right? Energy companies in general, I think, tend to be a little bit slower moving just because of the repercussions of failure, right? And so AI is still a relatively new concept, right? It's been around for a long time, but only in the last couple of years has generative AI become mainstream. And the demo that we just saw is my first time seeing it, is incredible, and it's a great first step in moving in the right direction. What you'll find is that the back office things and Q&A and knowledge worker type applications are coming on fast, right? Not just for energy, but all industries, because most workers spend a lot of time looking for data. Especially in this industry, we've collected data for decades and decades, and that data is very useful, but it's only useful if you have time to go and look at it before you make a decision or have to make a decision. What this does is it allows our workers to focus on their tasks at hand and allows them to get knowledge that is available very fast, but then how do you make sure that knowledge is accurate? And this is where industry-specific models and RAG applications, like Matt talked about, is critical. And we see utilities look into this first because they have data. They're working with service delivery partners and companies like WWT to build out these kind of pilots and prototypes. We then see other companies who are more aggressively moving these type of workflows and AI workloads out farther to the edge, and how can it help control operations, right? And we've invested quite a bit in smart meter technology and edge technology in ways in which utilities can harness the value of these distributed energy resources that are being placed around the grid, right? And eventually the data coming off of those will feed larger models and help make informed decisions as to where you have excess capacity, where you're going to need capacity, and eventually be able to provide real-time capabilities to decision makers in ways that we haven't seen possible in the past. The grid is changing at such an exponential pace, and I anticipate that that's going to continue to happen due to regulations and push for electrification. And this is where I think really understanding what's coming onto the grid, what's available, and how to best leverage it is going to be things that humans can't respond to quick enough. And so the ability to build models and understand that, we've seen some very innovative utilities start down this process already. We see the DOE with a lot of their funding, now funding initiatives to see this happen. A lot in the OT space as well, where they're starting to look at OT cybersecurity and how they're going to protect threats on that. So we're at the early stages, but I anticipate that we're going to see a lot quicker adoption of this than other technologies. But there will be a human in the loop for a long, long time, making sure that the data is coming out of this is accurate. And I think to Matt's point, it's the workforce. You looked over at us saying, I don't know if you guys would understand this, and I wouldn't, because I don't work on those things. That's why engineers and power systems people and all of those will be critical to make sure that these AI bots or agents or co-pilots or however you want to refer to them are asked the right question. They become prompt engineers, right? Are we asking the right questions? Are we training on the right materials? Because only people who've worked in this industry before know if this information's accurate. And if you don't build an accurate model, if you don't build the correct prompts, if you don't build the right agents for an application, you'll get back answers that are not reliable. And so the great thing I'd say about this industry as well is we see a lot of collaboration, very different than we see in other industries where they're very competitive in nature. I think this industry is going to come together through larger organizations like UBA or EPRI or others to pull together resources and create industry-specific models that everybody can benefit from.
Thanks, Mark. Ken, I understand you and the fine folks at Nokia are also working on to address similar needs. You want to speak a little bit about what you're doing?
Yeah, that'd be great. I think just to build on some of the points that Matt and Mark have made, when you showed an example of our DMX platform, for example, and there's tens of thousands of documents, release notes. If you want to load those, train your model so that it can be accurate, then you have to do that, as the panelists talked about, more effectively. So one of the biggest things that maybe a vendor can do to help out customers adopt an AI strategy or be able to just go through AI adoption is to supply tools to make their jobs easier. If you're trying to train an AI, for example, instead of doing very large language models, which can result in hallucinations, maybe what the better thing to do is to supply smaller snippets of documentation that's already prepared to be consumed for training a model, instead of a large language model and waiting for it to ingest tens of thousands of documents. Make it so that it's consumable so that some of the hallucinations can be reduced to make the time to adoption faster. Because, just like Mark said, the most effective tools that we're going to see during this AI is kind of still in its hype cycle, right? And I think some of the more creative things that we're going to find that are available haven't been thought of yet. So while we're doing that, creating tools that allow for human and machine strengths to be used in parallel are going to be the best places that we can promote AI adoption and to invest money in things like this digital assistant, where we could build models, smaller models instead of large language models, to make them consumable or to help train, will help the utilities be able to troubleshoot faster and more accurately, and ultimately that's what we need.
Awesome. Thanks, Ken. Mark, could you share a little bit with us about a lot of this advancement sits on the kind of infrastructure that NVIDIA is developing. Can you share a little bit about what's enabling this and where you see that going?
Sure. So 5 years ago, if I came to this conference and I asked how many people were familiar with NVIDIA, I'd probably see a few hands go up. NVIDIA has grown tremendously over the last 5 years. And the reason for that is we make the underlying accelerated computing platform, right? And I love seeing other companies up here that are leveraging our technology, and we tend to be in the background, right? Providing frameworks and libraries and platforms and other things so that other people can build solutions on it for the industry. Most people think of us as a hardware company, and we do make really fast silicon, but we don't provide that silicon typically to end customers. We provide it to integrators and things like that. Where we work with end customers and where we work with software providers is on our software platforms, because that's really solving the problem. And then you choose, where do I need to solve that problem? How big a problem is it? And how fast do I need to solve it? And then you adjust your silicon accordingly. Do I need it in a small chip that sits inside of a robot or inside of an edge device on somewhere along a grid? Or do I need it for training and it's petabytes of data and it needs to be in a data center and there needs to be 1,000 of them in order to train it? So the way in which we approach a problem is very different. And I think to Ken's point, we say a lot at NVIDIA, as much as necessary, but as little as possible, right? We don't want to solve every problem with the biggest tool that we have, because sometimes that tool is not efficient, right? And so if you look at the demo once again, it was asking specific questions. You didn't need to understand how the kids got to school or how to bake a cake or all these things, right? That would be included in a generalized model that could be a trillion parameters or something like that. What you want to do is create specific models that have enough information in them to answer the questions that the users are going to use, but then have the capability to look outside that model if that answer can't be received. And that's where today we talk a lot about training models, because that's the phase we are in this industry right now as we come to this next industrial revolution of AI and knowledge. But the goal would be is how do we create models that are capable of doing these things that we're specifically asking, and no bigger, so that we can take those models and move them out to the edge, move them to a laptop for a field operator, make them available. But as we inference or ask questions, today we don't have a ton of users doing that. But eventually, if you think about your organizations, you could have tens of thousands of users or customers hitting this thing with questions. And each time they do that, it's inferencing, it's answering a question, which requires compute resources. So you want to be as efficient as possible and not always throw your largest model at a problem that a very small model can serve. So I think to that point, we're going to see companies and industries creating a lot of models. They're going to have, call it AI factories or foundries, where they're going to train models for different departments, different skill sets, and try to keep those models as specifically as possible, but with the ability to jump from model to model when they don't get the answer that they're looking for. And eventually you could go to a generalized model, but that might be of last resort just because of the amount of time it's going to take to inference across all of that data and the size of the model.
Awesome. Thanks, yeah. A lot of evolution we obviously see coming in the next couple of years. I guess to bring it back a little bit to today, Matt, can you share a little bit about what you're seeing early on? You mentioned we're only a couple of months into this, but some of the benefits that you're seeing. So any lessons you've learned, and tactically, like what are you doing next?
Yeah, definitely. Like primary, the big benefit right now is just empowering those people on the front lines, right? Giving them that information and the ability to make a choice, a decision of next steps to troubleshoot very quickly, right? I think what's next is a little bit more exciting as we bring that infrastructure into our on-prem and start to bring in things like telemetry data from our network, right? Look at alarm data, look at historical tickets, and now build models that enable more predictive analytics. In the future, we're looking towards even like self-healing, right? Can your AI interact with automation you're building around some of these known problems and known remediations to already ingest that data, recognize the problem and trigger some automation to solve it, right? A lot of lessons learned definitely as well. I think one I'll harp on a little bit here that we've talked a little bit about is adoption, right? And that is super important when it comes to AI. You look at who we are building this AI for, right? This is our NOC. These are people who are very proud of themselves from the work they can do, and they should be. They're managing a lot of technology, right? And now you're asking him to introduce this. By a show of hands, who out here has used ChatGPT before? Yeah, awesome. Yeah, like 75%. Who's used it like back in 2022 when it first came out, right? Yeah, a handful of people. So you can see, that's so relevant to people even today, right? And if we're providing something similar to our NOC, we really need to work on adoption with them and making sure that they see the value that we believe it's going to provide to them, right? So making sure you bring those people that are going to be the users of your AI along with you in the journey, getting them involved, getting them excited, showing them the value, right? Those people have a lot going on and a lot of pressures on them, and you can build these narratives around how this is a support system for them and ultimately going to make them look better in the work that they're doing. So that's a big one, I think, take home for you guys.
Awesome. Yeah, continue to think along the lines of the future. I guess, Ken, any thoughts on future use cases that you're excited about?
Sure. So I think probably Nokia's first full AI product is going to be based on NVIDIA chips. We're going to call it a HAL 9000. As long as you guys don't have any technicians named Dave, you're safe. I think that kind of going forward and building off of the current tools, small steps that are effective, that can help people get their jobs done. We see that there's a lot of focus on automation, on machine learning, and we think that AI can be applied to make those either more accurate or more efficient, again, leveraging strengths of AI in parallel with what humans can do. So those are going to be probably focuses that you're going to see over the next couple of years, at least until we hire some really smart young person that comes up with, the next thing that we didn't even bother to think of yet.
Yeah, I love it. With this, I often think about like the 4G and LTE network was not built to support Uber and Lyft and change the way we get around when we're not at home, even for some of us when we are at home. But by creating that foundational technology, we've built all these tools that have changed our lives. I think I speak for the panel here when we say like it feels like that kind of moment. Same question, Mark, any thoughts on sort of use cases you're most excited about in the space?
I'm probably most excited about edge use cases. I really think the edge use cases are going to provide a tremendous amount of value. I think there are plenty of use cases for agents and back office work and things like that, and those are going to come at a fast speed, and we're going to see a lot of those come through software providers as well, where software providers are going to have co-pilots and agents and things, and those are going to be great. And then there will be a lot of software companies that come out and build broader ones that connect together multiple software, so you can not only go through your operational data, but your SAP data and all these things. So when you see an issue, you can ask, do I have those in stock, and where's the closest one, and can I get it delivered, and create a field ticket, and all of those automation things. But I think the edge is going to be really exciting for just the amount of data that is generated at the edge that today we can't get back to the data center. It's possible, I guess. The networks are strong and people can move data back to the data center, but I'm thinking really high resolution data where maybe you can see the difference on lines between a squirrel and a tree and what that looks like. And that's a simple example, but I think we're going to see a lot of optimization that can be done. I think we're going to see a lot of supply chains that are eased through understanding the loads on transformers, and that our ability to make adjustments in real time to prolong the life of assets and or to understand where assets are going to fail before they do. I think those types of things are going to change the way in which we work and provide services and reliability and resiliency to our customers, because we're going to be able to capture that data and send anomalies back. And we see this in the autonomous driving in the EV world today, right? Where you've got certain companies that are software defined in a much stronger way, that have millions of sensors driving around the street, and when they learn things and find things and better ways of driving and how to be more efficient battery life and all this, when those things park at the end of the day and they collect the data and they retrain the models and push them out to back out to the vehicles, everything gets smarter, right? It's one fleet of a million, not a million fleets of one, right? And today I think we're going to start to see this as we have smarter, more capable edge devices being deployed, where we're able to update models over the air and basically make everything just that much smarter, and potentially doing a lot more use cases than we've ever thought about. The iPhone's, I think 16 or 18 years old now, and it started with 500 apps, and there's 2.5 million today, of which I'm sure there's not two people in this room that have the exact same apps on their phone, right? Everybody has a different need, and every part of the grid's going to have that different need, and the ability to make adjustments fast and update software fast, that capability is going to be there.
Awesome. Well, we only have a couple of minutes left, so we're starting with Ken and working our way down. Some closing advice. What are one or two pieces of advice you think folks in the room from utilities today could use to get started or take with them from this talk?
I think probably the two biggest things that I pointed out so far. I'll just reemphasize both of them are, instead of doing giant large language models, maybe just start with smaller data sets that are consumable that you can make sure are accurate. And then the second piece is, you know, if you're looking at grid power delivery that is reliable and safe, that means the tools that you're going to rely on with the AI need to reduce risk. They need to be trustworthy to the humans that are going to be using the tools. And so if your data set is cleaner, it trains your AI in a more accurate way, then you can reduce the risk. Your technicians will trust it, and those are going to be the tools that they use the most.
Yeah, I think for me, the two big ones would be to just kind of get started now. I think that everyone has use cases they can start to implement today, even simple ones, kind of taking from the example we were after, and then, you know, expand upon that and scale upon it. There's so much learning out of just implementing a simple use case that drives way bigger complex decisions around what does our infrastructure need to be like in 5 years, right? The other one would be finding good partners to support you with this, right? We've been very fortunate in our partnerships with WWT, NVIDIA, even Nokia, right? And kind of leveraging those. I mean, we talked about building this RAG model around some Nokia documentation, right? And I know Nokia has been doing a lot of really cool AI stuff. So they are the experts in their technologies, and they're providing now AI solutions. So meet with those vendors, see what they're providing, right? And build your strategy strategically with them around the different things they're providing.
I guess one thing we haven't touched on that we should is we've touched on large language models and small language models, which I agree, Ken. I think small language models is going to be critical. But there's also VLMs now, video language models. And if you haven't seen these yet, it's pretty amazing stuff, right? And when AI started, it was how do you identify a cat versus a dog and things like that. But now you can actually feed it videos and understand, you know, what's going on in those videos, as well as what could be happening in those videos. And I think with companies that have large amounts of video data, drone data, all of these things, the ability for these video language models to be able to describe what's going on in a very fast way without having to have people sit and watch these videos. And we're not talking about just, you know, intrusion detection or things like that, but you know, while they're going on, to be able to alert and actually explain to you what's happening in that video, not necessarily just set off an alarm, but actually describing it, whether it's the spread of a wildfire, whether it's spark detection, whether or not firefighters are on site or not, without having people physically present there, or the ability to log in and watch multiple video streams at the same time. These video language models are truly amazing. It's relatively new in the way that they're working, but it's really going to change a lot of industries.
Awesome, thanks. And I'll throw two out there. One, I agree, get started. You know, we don't really know the direction this is going, so don't try to, you know, I think we have all been, we've all gotten into analysis paralysis, so finding ways to get started and really just be iterative. The other side is, while you want to get started quickly, also take a look at your data center. What we're finding is the vast majority of data centers are not ready to go scale this and put it into production. So while you want to act quickly, also think about the long term and how will you scale it. So anyway, thank you very much. Thank you to the panel, and looking forward to the next couple of days with everyone here.